Question 8 of paper 2 for June of 2024. Question 8.1. In the diagram, the chords AB, BC, and AC are drawn in the circle with center O. DCE is a tangent to the circle at C. Prove the theorem which states that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. In effect, prove that BCE is equals to A. So in this proof, they give us a little bit of guidance already. They want us to prove that angle BCE is equal to angle A. So in order to answer the question, I would need to do a construction, and you do that construction on your answer sheet. What I also prefer to do is I prefer to number the angles that I formed. Can you see that I've constructed the line CF and I connected that to AF? So please do that with a ruler. Now for the proof, I can say that angle C1 plus C2 is equal to 90 degrees, and the reason is tangent perpendicular to the radius. And I can say that angle A1 plus A2 is equal to 90 degrees because the line that I constructed is the diameter of the circle. Therefore, the angle of the circumference is 90 degrees. So that is angle semicircle. But you can also see that the angle of A1 would be equal to the angle of C1. So I would say angle A1 is equal to angle C1. And the reason is angles in the same segment. And because A1 and C1 is equal, it means that they can be interchanged in our first two equations. And therefore, we can conclude that angle C2 is equal to angle A2. Therefore, we can say that angle BCE is equal to angle A. Question 8.2. In the diagram, PQRS is a cyclic quadrilateral with RQ equal to RS. ST is a tangent to the circle at S. SR is produced to N. And R2 is equal to 68 degrees. So I'll mark R2 as 68 degrees. Determine with reasons the size of, and then in 8.2.1, we want to find P. So in our cyclic quadrilateral, we have the exterior angle as 68 degrees, and P is the opposite interior angle. So P would also be 68 degrees. So we can say P is 68 degrees, and our reason, exterior angle of a cyclic quad. 8.2.2, find Q1. So Q1 is part of an isosceles triangle. And when I highlight that triangle, I see that the exterior angle is already given. So we know that R2, that's equals to 68 degrees, and that was given, but also that R2 is equal to S2 plus Q1. And the reason would be exterior angle of a triangle. But we can see that Q1 is equal to S2, and the reason is angles opposite equal sides. So we're making S2 equals to Q1. Therefore, Q1 would be half of R2, and that is 34 degrees. So can you see that R2, which is 68, will be equals to Q1 plus Q1, and that is 2Q1, which is 68, and when I divide by 2, I get 34 degrees. 8.2.3, find S1. So the angle of S1 is the angle formed between a tangent and a chord. And we know that S1 would be equal to Q1. So we can say S1 is equal to Q1, which is equal to 34 degrees. And our reason is tan chord theorem. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.